Hi guys, good to see you again. Mr. Kane here.
Good morning, guys. Mrs. G here. Where's Millie?
Millie? Oh!
She's gone.
She flew the coop.
I let you watch her for one day and you lost her.
I'm sorry, I'm not good with pets. Oh,
honestly,
boy.
Mr. Kane. What are we doing today, Mr. Kane?
Alright, today we're going to discuss mass to mole conversions and volume to mole conversions.
Ooh, more math.
A little bit more math. This is not hard stuff though.
It is if you don't have a calculator.
It's also hard if you don't have a periodic table.
Oh.
Alright, so once again, going to the idea of counting atoms. Atoms are way too small to count, so we count them indirectly. The way we do that is we use a mass or a weight to indicate the count indirectly. Alright, we need to know just a little bit about average weights, and then we can do the math.
Like in bulk.
Yeah, for example, when you buy in bulk, you go to the mall and you buy jelly beans in bulk from the candy store.
All right.
Yeah. So they charge you by weight. They actually know how many you're buying. They can figure it out. All right, so how do we apply this to chemistry? Atoms and molecules are just like those candies. They're small collections of things. We can know the mass of each type because they each have an average mass.
Right.
We can find the average mass on the periodic table.
Okay.
Right? So we can use the average mass to figure out how many atoms of each type exist in a given sample.
All right.
All right? And the simple idea is this. The masses on the periodic table are atomic mass units.
Which is an arbitrary unit scientists picked to indicate something super small, wasn't it?
Mm-hmm.
Okay.
So we've got this idea that one carbon atom weighs 12.01 atomic mass units.
And they used carbon as the standard of comparison because it's so abundant, yeah?
Exactly, yeah.
Okay, I can see why they used carbon.
And carbon's everywhere. What that means is if we have a sample of carbon that masses 5.00 times 10 to the 20th AMUs, we can actually figure out
how many atoms there
are. Okay, and it turns out that the periodic table gives us the conversion factor that we used, which is one carbon atom is 12.01 AMUs. But what we do is we set up a conversion.
Dimensional analysis. Factor labeling. What else is this thing called?
Exactly. So what we do is we do exactly what you'd predict. We use the bottom to try and cancel out the top. So we use AMUs on the bottom.
Okay.
All right. So 12.01 AMUs goes on the bottom. That means that one carbon atom, the other part of my ratio, goes on top.
So that thing, that very first line in red, one carbon atom is equal to 12.01 AMUs, is the conversion factor.
Yeah, it's a conversion factor.
Okay.
Matter of fact, we could get a conversion factor for any element on the periodic table we want.
Ah, okay.
One hydrogen atom would weigh 1.01 AMUs.
All right.
Of course, you don't get hydrogens in single atoms, so
No,
one hydrogen molecule would be 2.02 AMUs.
All right.
All right.
So as long as you have the ratio in front of you and you put it in the right, how would you phrase that? If you put it, wrote it right, your old units are on the denominator and the new units are in the numerator, so follow the units.
Follow the units.
Okay.
So AMUs and AMUs are going to cancel, which I should probably show happening here. AMUs and AMUs, and we're left with atoms. So 5 times 1 divided by 12.01 gives us, well, our sample had 4.16 times 10 to the 19th atoms of carbon.
All right, so that's the answer to that. That's interesting. All right, that's easy.
That's an interesting answer, right?
Yeah, that's pretty good. It looks feasible.
It looks pretty easy. And it's actually not too tough to do, is it?
All right, nope.
So this brings us to an idea called molar mass.
Okay. Molar mass is the mass of 1 mole. Okay, so here's the definition of molar mass, which is super important. Molar mass is the mass of 1 mole of a substance, measured in grams. The units for molar mass are grams per mole, which you should be able to glean from the mathematical computation where its molar mass is equal to mass per number of moles. 1 mole. Always just 1 mole.
Okay, so if I was trying to find the molar mass of carbon, how would I do that?
Well, 1 atom of carbon is 12.01 AMUs, and if I have a mole of carbon, which would be 6.022 times 10 to the 23rd atoms, or 6.02 times 10 to the 23rd atoms. So a mole of carbon has lots and lots and lots of atoms in it, so it would be 12.01 grams.
12.01 grams. Where did you get the 12.01 from?
I looked up at the periodic table and realized that since one atom is 12.01 AMUs, then 1 mole must be 12.01 grams.
That makes sense.
The mole is a nice bridge from the subatomic to the macroscopic world. How do you mass out an AMU, Mr. Kane? That's impossible. You can't. We don't have that kind of equipment.
No, we don't have that kind of equipment.
So we can do it in grams, and that's our bridge from AMU to grams is the mole.
Now this is a little weird writing it. Could I also write it 12.01 grams per mole? Whoops, I forgot my 1. 12.01 grams per mole? Yeah, I think I could.
That's correct.
So both versions of this work. It's
Right.
understood that there's 1 mole here.
So molar mass can apply to elements, and we use the periodic table. All right.
I think this is the example. Huh?
And every one of those masses in grams comes from the periodic table, and they are all the mass of 1 mole.
Right.
Now take out the grams and put in AMUs, and you got the masses of 1 atom, right?
Right. You have to take out the moles and change them to atoms and change the
Yeah,
grams to AMUs.
okay.
If you switch the units, you can do it 12.01 AMUs is equal to 1 atom.
Okay, so again,
For
the mole,
carbon.
there's just a lot of atoms in a mole, so the mole gets us to the grams.
Right.
It's a bridge. Okay.
It's a bridge. It's a mathematical bridge. Now, molar mass can be done for compounds as well as elements.
Okay.
Okay. So we still use the periodic table to find the mass, but we need to know, like for example, calcium chloride.
Ooh, we need to know our ions too, don't we?
Yeah, we need to know our ions. We need to know how to predict charge. Okay, so we know that calcium is a 2 positive charge,
Correct, because
And
it's in
that-
family 2.
and that chlorine is a -1 charge.
Right, so this is an ionic compound.
It's an
okay.
ionic compound. In order to get enough negative charges to overcome my positive charges, I need 2 chlorines.
Right.
So my formula is going to be CaCl2. And what do you know? It's written right
There
there
it
for
is,
us.
yep.
Now, in order to find the molar mass, I need to add up 1 calcium and 2 chlorines.
So we're finding the mass of the entire calcium chloride
Right, the entire-
formula unit.
the entire
Ooh,
compound,
not
yeah.
formula unit, a mole of.
A mole of.
Okay.
So we're going to take 40.08, add that to 35.45, and add that again to 35.45.
And you get 110.98. So a mole of calcium chloride is equal to 110.98 grams. And that contains 6.02 times 10 to the 23rd formula units of calcium chloride, right?
That's correct, yeah.
Okay, got it.
Okay.
Ooh.
Calcium carbonate, now you have to know your ions. Check this
Yeah.
out, because if you don't know your ions, you're not going to be able to predict the formula, so you can't predict the mass, the molar
Okay,
mass.
so you have to know it right.
So again, calcium is a 2 positive. Carbonate is a 2 negative, so I only need 1 of each here.
Yep, it's a 1-to-1
Okay.
ratio.
So that's CaCO3. And now I need to add a calcium, a carbon, and 3 oxygens.
Okay.
So 40.08 plus 12.01 for carbon, plus, now you see I did a little math there, 3
Yeah.
times 16, because there's 3 oxygens, each
Okay.
of 16. You get 100.09 grams per mole is the molar mass for
So
calcium
1
carbonate.
mole of calcium carbonate will be 100.09 grams. And in that mole will be 6.02 times 10 to the 23rd formula units of calcium carbonate.
Very good.
All right.
Sounds about right to me. An example of how to calculate moles from molar mass.
Hey, that looks like a conversion factor.
Yeah, it is a conversion factor, and it looks actually pretty similar. If you notice, before it said atoms and AMUs, and now
Right.
it says moles and grams,
Grams.
like you had pointed out earlier.
Okay.
We can swap those words out, and they become the meaning becomes different, but the ratio appears to be the same.
Okay.
So now we've got a sample of carbon that mass is 5.00 grams.
All right.
All right, exactly 5 grams to the hundredths place. How many carbon atoms do we have? Well, we pull our molar mass off the periodic table. We start with 5 grams. Our molar mass on the periodic table tells us 12.01 grams
Uh-huh.
is 1 mole.
Right. There you go.
All right. So grams and grams cancel, and we get moles.
Okay, so if we go back to the original question on the top line, we have a sample of carbon that mass is 5 grams, and we can intuitively assume it's less than 1 mole because 1 mole is 12 and we only have 5 grams.
Mm-hmm. Yeah.
Okay.
So we can actually check our calculator and make sure that it didn't give us a bogus answer. If it said 41, I'd actually want to double check.
Yeah, because half a mole would be about 6 grams, right?
Right.
And we're still under.
It's,
all right.
It's somewhere underneath half a
Yeah,
mole.
that makes sense.
Mm-hmm.
Okay.
Here. Molar volume. All right, so molar mass works nicely to measure solids, liquids, and liquids. But what about gases? Gases are a little hard to weigh sometimes.
Yeah, they're hard to catch.
Because sometimes even if you can put them in a balloon, the balloon you can't put on a balance because it floats.
It keeps floating.
Right? It keeps
yeah.
going up.
How do you mass a balloon? That's
Yeah.
interesting.
I mean, some balloons you can mass. If you just blow it up with your breath, you can mass it. But if it's a hydrogen balloon or a helium balloon,
Yeah, it's going to be tough.
It's going to rise. So they came up with an ideal situation. 1 mole of a gas winds up taking up 22.4 liters.
So you have a conversion factor staring you in the face.
We have a conversion factor staring us in the face. A third conversion factor.
Another
here.
one, okay.
All right. Now this one, if you want to imagine it, it's a little bit more than 11 pop bottles. Okay, 11 2-liter pop bottles, 22.4 liters.
Oh, okay.
Okay. And like I said, we do this at under ideal circumstances, so called standard temperature and pressure.
So there's a restriction on using that conversion factor.
Yeah, because it turns out that at lower temperatures, gases do different things, and higher or lower pressures, they do different things also.
All right.
So you have to be at this standard temperature and pressure. And for right now, I don't think our chemistry students need to know the exact values of standard temperature and pressure, do they?
Well, it's not hard. No, it's not. It's not necessary. They'll just be doing exercises with 22.4
Yeah.
liters in 1 mole right now anyway, until we get into the gas law chapter, right?
Yeah. And so for right now, you might see some problems that say at STP. What that means is it's at standard temperature and pressure, and it means you can solve it.
Okay, so if
Okay.
you're given 82 moles of a gas, what volume is that? And at STP, you just do the conversion, right?
Exactly. You just do the conversion.
They can do that.
All right. No, this only works for gases, so you can only use it for gases.
Okay.
Okay. And don't forget, there are diatomic elements that are gases. Not all of these are gases, though, right? Hydrogen's a gas, nitrogen's a gas, oxygen.
Iodine's the only one. Oh, well, bromine is a liquid.
Yeah, bromine's a liquid,
and
iodine.
bromine.
So any of these 5,
Hell no halogens?
the hell no halogens, any of the five of the hell no halogens can be used for molar volume.
Well, that'll apply also to the noble gases, too. Aren't they all gases at
This
room
is true.
temperature?
Yeah, helium, neon, argon,
So
krypton,
that,
xenon, radon.
yeah, that 22.4 liters will apply to any gas on the periodic table
Yeah, or methane.
at STP. Yep. Methane, ammonia gas.
Oh, yeah. Okay. All right. So if we're asked a question like how many moles are in 1,801.23 liters, wow, that's very specific.
Yeah, really.
That's big. It's a lot. All right. So what we do is we just do the math. 1,801.23 liters. We set up a conversion factor. 22.4 liters wants to be canceled. Wants to
Okay.
cancel out the liters up top. 1 mole. We're going to find out how many moles there are by doing the math.
Oh, that's way too
1,801.23
simple.
divided by 22.4. You get 75.0513. Now, the funny part about this, again, this is a conversion factor, so just a reminder, infinite sig figs here and infinite sig figs here. So I'm concerned about my number of sig figs here.
Okay.
So 6 sig figs means that I have to write all 6 sig figs
All right.
here.
Okay.
Okay.
Ooh.
This is it, guys. This is your homework. We're at the end.
Read it carefully, people.
Again, clean sheet of notebook paper. Put the title on top.
And your name.
If you don't put the title on top, I'm not grading it.
And show your work.